Hi and welcome to this screencast on loops. Today I'm going to give a short introduction to for loops and while loops, and I'm going to say a few words on loops versus vectorized computation. Now before we start, let's just remind ourselves how we can create a vector that contains consecutive numbers. So let me create a vector v and assign the value of the numbers 1 through 5. So this will create a vector that contains the numbers 1, 2, 3, 4, and 5. Now I can go ahead and write a for loop. Let me write for, and I'll type I equals 1 through 5. So now we can see here, what I've written here is for, the keyword for, and then a name of a variable here, and I assign the value of the vector 1 to 5. It seems like I assign the value of the vector, but what I really do with the keyword for is I tell the computer to set I equal to each of these individual values in the vector and then do something for each value. So I can type end here, and then what I want to do with I is going to be here in the middle. So just for fun, let's start by printing out what I is. So I can write this I, and when I run my code here, I just save it, for loop.m. When I run it, it will run through all the values 1, 2, 3, 4, and 5, and for each value it will just print out the value. So the first time it runs this line of code here, it will set I equal to 1 and then display that. Then it will be I equals 2 and display that, and so on until I equals 4, which is 5 is displayed at the end. Right, so basically a for loop is just a way of telling the computer to repeat a line of code multiple times. And in a for loop you have to specify in advance exactly what to loop over. So in this case I loop over the vector 1 to 5, like this. Right. Now just printing out these values is maybe not so interesting. So what we are usually interested in is doing some sort of computation in here. So let's say, for example, that we want to compute the sum of all the numbers from 1 to 5. And what we could do would start out by defining a variable sum and set that equal to 0. Okay. Now in our loop, now what we could do is we could take the current value of sum and add I to that, and we can save that in the variable sum again. So we update the value of sum so that it's equal to its current or previous value plus I. Right, and just to keep track of what's going on, let's display sum at each step. Right. So what happens when I run this code is that first sum is 0, then we loop over different values of I starting with 1. So sum is 0, and then we add 1, and then sum becomes 1, and we display that value, so it prints out 1. The next loop, iteration of the loop, I is 2. The old sum was 1, so it adds 1 and 2 and puts that into sum, so now sum is 3, and it prints that out. And next iteration, I is going to be 3. The previous value of sum was 3 as well, so it adds 3 and 3 to give the result 6, which is then printed out, and so on. And the final result is 15. That's the sum of the numbers from 1 to 5. So if we don't want to follow each iteration here, we can just maybe print out the final value, and if we run the code here now, it's just going to print out 15, which is the total sum. So in a for loop you had to specify exactly what numbers to loop over. So in advance you had to specify exactly how many times the loop was supposed to run. Sometimes you don't know that in advance, and in that case it can be good to use a while loop. So in a while loop you don't specify a vector to loop over, but you specify a condition that must be satisfied, and as long as that condition is true, you're just going to repeat looping again and again. So let's say, for example, we have a variable x that has the value 5, for example. I'm going to write a while loop that says while x is less than 10. So as long as x is less than 10, I'm going to repeat the following lines of code. Right. So of course, if I just do it like this, it's going to run forever because x is 5 and it's always less than 10. So somehow I need to modify x here inside my loop. So if I change x in a way so that at some point it'll be less than, not be less than 10, then the loop is going to stop. Right. So for example, I could just take my x and update that to a new value, which would be the old value of x plus 1, for example. Right. Now, just to keep track of what is happening, I'm going to print out the value of x after this update. Now let me try and run this code. See, we can see now it prints out the numbers 6, 7, 8, 9, 10. So let's try and understand why that happens. So to begin with, x is 5. And now we say while x is less than 10, I'm going to repeat the loop, right? So since x is 5, it's less than 10, this is true, so I'm going to run this part. And the first line here adds 1, so x becomes 6, and it displays the value 6. Now we go back to the loop and check the condition again. Is x still less than 10? Well, x is 6 now, and it's still less than 10. So we're going to run once more. So we add 1 to x, x becomes 7, we display that, and we go back and check the condition. Now x is 7, is that less than 10? Yes. We add 1, display, and go back and check the condition again. Right. So at some point x is going to be 9. Then we the condition is still fulfilled, 9 is less than 10, and then when we execute the part of the code here, x gets updated to 10, we display 10, then we go back and check the condition again. Now x is 10, that's not less than 10, so the condition is false and the loop is going to stop. And now the program is just going to skip over and continue executing whatever code we may have down here, right? But in this case the program will just stop because there's no more code. Now you learned about vectorized computation already, and now you've also learned about loops. So sometimes loops and vectorized computation can both be used to solve some task, but in different ways. So let me try to illustrate that. You've previously seen an assignment where an exercise where you were asked to take a vector of numbers and then compute the square of each number, but keeping their original sign. So the square of 4 would be 16, but then you have to return minus 16 because there's a minus sign in front of 4. And the square of 1 is just 1, so that should just be positive 1, and so on. And one way to do that could be to use vector indexing. So for example, let's take all the values of v where v is negative. Now we take all those values and we set them equal to their current value. That's just the same expression here. So I take all the values of v that are negative and set them equal to what their current value is, and I'll now square those values and put in front of that a minus sign. Okay? So this will actually, if I do this, this will square all the negative values of v and put a minus sign in front of it. And now I can do the same for the positive ones. V greater than 0 equals v greater than 0 square, and now no minus sign. So this will actually do exactly what we were asked to do, square all the values but keep their original sign. Let me just display the results, and we can see it squares all the values and keeps their original sign. Okay, so this is kind of nice compact way of approaching this result, but in some sense it would be very logical also to solve this problem using a for loop. So let me try and solve this problem and use a for loop now. So now I'll just create a for loop that just loops over all the values in v. So I'll just say for, and I'll make a variable I that indexes the numbers in v. So I'll start at the first one and go all the way to how many numbers there are in v. That's the length of v. Now what I'm going to do is I'm going to use an if statement that says if the value of v that we're pointing to right now is less than 0, then I'm going to set it equal to minus its square. Else, I'm just going to set it equal to its square. Right? So this is the solution as well to the same problem as before. let me print out the solution here. I'm just going to run this part of the code. We can see the result is identical. So this solution up here uses one vectorized computation for all the negative ones and sets them in one go, and then one computation for all the positive ones. And this solution with the for loop just runs through all the numbers and uses an if statement to change the values. Actually, we could make an even more compact vectorized solution, for example, like this. We could simply take to define v as the absolute value of v times v element-wise. If we do that, we'll just have everything squared, but if there's a minus sign, it's going to disappear from because of the absolute value once, and then it's going to be here just once. So that's a very compact way of doing the same thing. And it also gives the same result. So to summarize, sometimes a problem can be solved either using a loop or using vectorized computation. The primary reason to choosing one method over the other would be that the code should be as readable and easy to understand as possible. If you're working with very large data sets, very large vectors, then usually a vectorized computation is going to be faster than a loop, but you have to try that out and see if that is true in practice. If there's no sort of speed issue, then you should prefer the type of code that makes the code most easy to understand, and both for yourself and to make sure there's no bugs in the code, and also for someone who's going to work with your code later on.